2, 1. So welcome to another episode of Beta Talk, and today I am joined by Graeme Fox. Graeme Fox is a member of BESA and REFCOM, which is a provider of F-gas schemes. I'm joined by James, and we'll talk a little bit about that. James Baker, who's a renewable heat engineer, both land and sea, so he's worked with all sorts of things, especially out on the sea, I think. And then also Lisa-Jayne Cook, who's a member of the Institute of Refrigeration and an engineer. And today we're going to be talking about split systems. We're going to be talking about refrigerants. We've got all sorts of lovely stuff for you today. So, Graeme, just did I get that right? So you are a member of BESA and you're a member of REFCOM, is that right?
I'm not a member anymore. I was a member of BESA when I was a contractor. I'm now head of technical for the BESA group, which includes REFCOM. REFCOM is one of the group companies.
So if you just explain to listeners what REFCOM is.
So REFCOM was initially started by a group of contractors who were members of BESA, or HVAC as we were called at that time, back in '94, I think it was. So long before regulations really came into being. And we set up REFCOM as a voluntary scheme so that we could demonstrate that we worked to a higher environmental standard than our competitors, that we were recovering refrigerant, all the sort of stuff that's mandated now that was voluntary at that time. It was just, to us, it was just the right thing to do. So that's why we created this scheme to have a register of companies that were audited to make sure they were actually doing the right thing. And then when the F-gas regulations came in 2006, DEFRA needed to set up a company registration scheme, and they didn't know how to do that, obviously. So they approached us and said, how do you do it? So we helped them create the UK's F-gas registration scheme. And they made us water down the scheme because what we were doing was beyond, above and beyond what the F-gas regulation was asking for. So then we ended up with a two-tier system. So we have REFCOM F-gas certification, which is the minimum mandatory scheme that everyone has to be signed up to. And then we have REFCOM Elite, which is the old voluntary code of conduct.
Okay, right. Now, Lisa, you're a member of the Institute of Refrigeration. What's that all about?
Well, it's a professional body for refrigeration, but we also now cover like heat pumps and air conditioning as well. And it's a group which we basically create guidelines and help people with technical issues, papers. Yeah, there's quite a lot to us.
Now, are you seeing sort of, obviously now we're living in this world, obviously my podcast talks about renewables. There's lots of my listeners that are really interested in renewables, and the first one I can't think of is a heat pump. Are you seeing this sort of movement towards this interest, both of you two?
There's a lot of product development going on at the moment. We're certainly seeing advances that would mean that it's a more practical technology to put into buildings now. Before, it was something that was nice, but it was something that was only doing really part of what you needed in a whole situation. So I think it is growing. It's definitely with the advances, we're seeing a lot more interest in it.
Yeah, and in terms of what we need to do as a country to meet our carbon reduction commitment targets as well, it's been pretty well documented that we need to be installing millions of domestic heat pumps to have any hope of meeting those carbon reduction commitments.
Now, you guys obviously have been working with heat pumps for a long time, because as we know, heat pumps are in the HVAC industry. Offices use them. We've got split systems that can keep us cool and keep us warm. So this technology isn't new, but it's obviously been evolving over time. One of the things it evolves with is refrigerant gases. Now, sort of, some of my listeners will be sort of aware that some of the new heat pumps coming out now might have propane in them. So just tell us a little bit about why propane is used as a refrigerant.
The interesting point there is there's this new term of natural refrigerants being cast around, which is propane, and CO2 is another one that we're seeing a lot of. Not so much in the domestic yet, but more in supermarkets on the CO2 side, they use that a lot. But the word natural comes about because it has a very low GWP and it's not a man-made product, it's a natural current product. But there's risks. So as we're going towards CO2, we've got high pressures, high temperatures. And with propane, we've got the flammability issue to consider as well.
So I know there's one of the famous boiler manufacturers in my industry has now got a new model, and theirs is propane. And obviously the advantage is you can reach higher temperatures. Now these units have to be outside, I take it, isn't it?
Well, they generally are, these air source heat pumps are, but something we can talk about a little bit is now we're seeing propane coming into the building a little bit more with split systems. There's regulations on what you can do in terms of how much refrigerant you're allowed in that product inside the building. And there's a lot of education to be done around that, I feel. People are not quite there yet as to how safe it is to put a few 100 grams of propane in your lounge. But also at the same time, we've got to manage those risks and learn to work with them, because propane as a refrigerant is a great refrigerant.
It is. It's a very efficient refrigerant, and where you mentioned that supermarkets have been using it. What they tend to have is a pack system where the propane, the refrigerant containing part, is actually out in a secure compound at the back of the supermarket, and it's not propane that's been piped in through the shop.
The building.
And that's really critical in terms of how they can comply with safety regulations. So we all have to work with EN 378, which is the safety standard, and that has some very strict restrictions on how much quantity of refrigerant you can have in occupied spaces in particular.
Yeah.
So I just want to make sure my listeners understand the difference between a split system and a monobloc. Are you able to explain that, James?
Well, split system is where you've got the condensing unit that's rejecting the heat, or the evaporator, depending if it's a heat pump or a refrigerating air conditioning system, and often they'll do both. So the compressor and one of the coils is outside the property, and then you just bring in the refrigerant on two lines into the building, and you've got a fan coil unit in the property that then is the evaporator or condenser, depending on whether you're heating or cooling. So that's a split system. And then a monobloc is obviously where you just got it all in one unit. And heat pumps in general, if we're talking about like heat pumps, a ground source heat pump, you're going to have it all in one place. And same with an air source heat pump. And the benefit of that is there's no refrigeration work to be done on the installation side. You're just plumbing water to that single unit.
So, Lisa, I think we're going to start getting, obviously we've had a hot couple of days. I don't know what the temperature's like where you guys are at the moment, but we've definitely had a lot of hot sort of weather, and people are chatting about, I think they're now starting to realise that they can use what they've got in their offices to have in their homes, like these split systems can do your heating and your cooling. And I think people are sort of moving to this idea. They want some, I mean, it's not really aircon, as we all know, it's comfort cooling, isn't it? But they can move towards that, having in their home. Now, is there problems we're going to see with that? Because that obviously would require an F-gas engineer to install that type of equipment, wouldn't it?
Yeah, I guess. I mean, obviously, if you go down the sort of traditional route, and we've discussed before about you can buy a boiler, but you're not necessarily going to install it yourself. It's the same with, replacing your brakes on your car. You could buy the parts, but you're not going to do it. And I think, as we said earlier, it's about education. We need to let people know how important it is to not be doing these things on their own, to actually employ somebody professional. But obviously, in the current climate, people have been laid off or furloughed. They don't have a lot of cash. There's the temptation to actually do it on the cheap. And I think that is the biggest concern, not only because of the gases, but, electrocution. There's all sorts of things that can go wrong with that type of installation.
Can someone buy a split system then? Can they just go out and buy a split system?
Not legally.
Yeah, not legally, but there are several websites. I've done a bit of digging around, and I found at least 3 or 4 just this morning that
so I could order one over.
I should caveat. I glibly said not legally. They can do it legally. Can I just explain what the actual regulation says?
Yeah.
So it says a non-hermetically sealed, pre-charged piece of equipment. So that's a split system that we're talking about, where you actually have to make a connection in the field, that's charged with fluorinated greenhouse gases. So that's not the propanes that you mentioned. This is the likes of the R14As and R32s. They shall only be sold to the end user where evidence is provided that the installation is to be carried out by an undertaking certified in accordance with Article 10. That's what the text of the regulation actually says. So it says it shall only be sold to the end user where evidence is provided that the installation is to be carried out by a properly certified undertaking. So that's not covered by some of these online sellers who sell it and say you'll only get a warranty if you send back this form, tell me who's installed it.
Yeah.
And that's what. And Lisa, you hit Lisa-Jayne, you hit the nail on the head there with the people are feeling the pinch a little bit with the money, so they may be more likely to actually go down a cheaper route. And also, you know, Nathan, you said about it's been really hot recently. It has, and there's more and more people working from home.
Yeah.
So obviously you've got a situation where people are used to going to working in a nice air-conditioned office, and they're now working from home all day, and it's swelteringly hot. So I think I need some air conditioning in my house to be able to work from here. But I can't afford to pay £1,200 or £1,500 to get this split system installed. I can buy it from this online seller for £500 or £600, and it says it's really easy to install, so I'll just do it myself. And that's what we need the education to kind of get around that. So that seller shouldn't be selling it under those circumstances because they haven't had evidence of who will be installing it.
So there's a bit of responsibility. These online sellers should really take a little bit of responsibility then for the equipment they're selling, I presume.
I think they should, and the way they advertise it, there are some out there, they're saying they are really advertising it as a DIY product. They use the words DIY, and that's just simply not the case. It's not a DIY product. You do need to have understanding of the regulations, and that applies. So with the F-gas, so all these existing refrigeration systems where you've got fluorinated gases in them, that is absolutely true with the F-gas regulations. There's a little bit of I wouldn't say it's a loophole, but there is a gap here now where we look at these natural refrigerants like propane. They're not an F-gas, so they fall under, if you're doing it commercially, like most people will be, it's HSE and DSEAR and all these other regs that you've got to do your risk assessments. You've got to, anyone you employ that works on it, you've got to cover them and insure them. So it's obvious that a DIYer is not going to have that knowledge of the standards.
That's actually a really good point. DSEAR, Dangerous Substances and Explosive Atmosphere Regulations. Yeah. That is the UK's implementation of the ATEX directive from the EU, which is that Explosive Atmospheres Directive. Now, the law changed about 1.5 years ago, where the classification of certain products under the classification labeling of products directive, I think it was, regulation, sorry, actually moved the goalposts so that any installation involving any refrigerants, not just the flammables that used to come under the ATEX directive, are actually covered with a need for having a DSEAR risk assessment done.
Yeah,
and that's a really good point, because you talk about you know, non-qualified people installing split systems in houses. They're not capable of doing a risk assessment for DSEAR.
No, they're not. No, I mean the big thing that with flammables is so you can go buy an R290 propane split system. It's not an F-gas. You're not breaking any rules by purchasing it possibly, but if you're going to install it, you need to understand the regulations. And the simplest first part you need to understand is it safe to put it in a room of a certain size, and there's flammability limits based on the room volume. And often with propane, you're never going to be able to find a room big enough to justify putting that unit in it. You're talking 20, 30 square meters of floor area for a few kilowatts of heat output or cooling. And that's something that's missed.
Can we just, for the listener, just explain the difference between propane and an F-gas? Because obviously I think listeners would have heard that some engineers have to be F-gas registered, so they've heard that terminology. Can you just explain what the difference is between an F-gas and maybe Lisa, you can do and propane?
Are you probably better asking Graeme that question?
Okay, fair enough. Okay, obviously refrigerants have evolved over the years. We had, you know, back when my dad was a young fridge engineer, we had miracle refrigerants like R12 that we later found out were destroying the ozone layer. It's because of environmental restrictions, but they've been evolving. We have the current usual batch, if you like, of refrigerants are fluorinated greenhouse gases. So they have a varying level of global warming potential, depending on what the F-gas is. A lot of them are already banned now. So some of the ones that were up 3,000, 4,000, 5,000 GWP global warming potential are now banned. Some of the medium range ones are still in use in larger air conditioning applications, for example. Most commercial refrigeration, as was touched on earlier, has now gone down the natural route. So they're using CO2 or propane and different pack systems and things. So that's fine. But there are limitations on what can be used, what refrigerant can be used in certain applications. So it might be a legal restriction because of the safety standards, or it may be just the physics of it, that the refrigerant just isn't suitable for a particular application. CO2 has enormous, amazing capabilities and flexibility in use, and it has lots of add-ons with lots and lots of heat being discharged that you can recover in different ways and use either heat domestic. I've seen a CO2 application where it was a huge walk-in cold room in Sweden, and the discharge was so hot that they had the entire hot water had something like 4 calorifiers that never ran as calorifiers because they were really just being preheated off this heat discharge off the CO2 system. It did the entire washdown of this warehouse. Amazing installation. Great things you can do. But critically, the lower the GWP of a refrigerant, generally the higher the flammability, or certainly higher the safety implications. So it might be very high pressure with CO2, or if it's going down the hydrocarbons route like a propane, then it's high flammability. So higher GWP is safer, but obviously more environmentally damaging.
Oh, that's quite helpful for, I think, for listeners to sort of. I mean, I know some of my listeners are all quite interested in sort of all these gases now. I mean, obviously, like you say, years ago we just started with, let me get it right, fluorocarbons, CFCs, which were ozone depleted, and then we went to hydrochlorofluorocarbons, which were also ozone depleted. Now, what would the bracket propane come under? That would be a hydrocarbon, wouldn't it? But like you say, it's got a global warming potential which is low, only 3, but it obviously has that flammability. Now, some people obviously know that we use propane all the time, don't we? We got propane people on LPG outside at their home for their boilers. So I just want listeners to realise that with a monobloc situations, it's outside, but with a split system, you have got refrigerant gas coming into your home, haven't you? And this is why F-gas and you guys who are trained and train people realise this is such an important aspect that consumers.
It's not just into the home though; it's actually being highly pressurised and pumped into the home under high pressure. That's the way a DX system works. You can say people are used to, they've got propane, so maybe people might get a bit complacent and think, oh, it's just propane. I mean, I've got a camping gas stove, I use that. The difference is that those cylinders have very controlled valves on them that allow a very small amount of gas out, so that when you light it, it's a controlled flame. Like in a barbecue, for example, it's a controlled flame that you can cook your sausages or your chicken on. But what we're not talking about that here. We're not talking about something with a controlled valve. We're talking about highly pressurizing a large amount of refrigerant and pumping it into somebody's living room, potentially.
Graeme, you've just made me hungry now mentioning barbecue.
Another important point on this, with the DIY side of split systems, is you've got the safety aspect. You've also got the performance and the reliability aspect. You've actually got to install these systems correctly. It's not a case of just connecting up the pipes, getting it in there, it doesn't leak. For a start, you're omitting pressure testing if you're not really qualified. You really should do a tightness and leak test on your lines. But also, you've got to get the moisture out of the system. So if you're putting new lines in, they've got air in there, a little bit of humidity. Air or moisture in a system is a very bad thing for refrigeration systems. You get acid buildup, essentially you can, similar to if you get a compressor burnout, you get acid in there. And that will destroy a refrigeration system pretty quickly. So to get around that, everyone that's trained in this business knows you've got to back the system out. Again, going down the DIY route, people are probably less likely to do the pressure test, they're less likely to do the vacuum before they fill it. So there's a lot, and that probably takes us on a little bit to training and servicing of those types of systems. If you're not really qualified, don't know what you're doing, there's a chance that you're going to have a real mess on your hands and rip it all out and start again in a couple of years or less if you're not lucky. So training is important, and there's some very good training courses around. People, I think it's been going around for a long time. Refrigeration systems, there's a great base for training. It's not new. So when we're looking at heat pumps, I don't see many split systems, but I think as the market grows, we could get into that where we have heat pumps that have an outdoor condensing unit and an indoor unit doing something with the water. But generally, it's more for these monobloc systems, heat pumps. The servicing is very minimal. We're lucky. Actually, for these systems, they don't really need servicing. You don't need to cut into refrigeration lines unless you've got a leak or you've got some kind of problem with some of the components. And generally, servicing for like air source heat pumps is keeping the fan outside clean, the coils clean, and monitoring the performance. And data logging is a great way of doing that. So the market is starting to take this into the renewable sort of side of things, but it's not quite there yet. There are people DIY. I mean, I DIY installed my ground source heat pump, but I wasn't a refrigeration engineer at the time. I didn't need to be. It's water connections. So we're not, I think for the renewable market at the moment, we're not really too concerned about refrigeration engineers, but there's people who wanted to install air conditioning systems or even heating systems that are split, then there is that issue.
Could you see a sort of a move, if this sort of takes off and gets really big, the heat pumps in the renewable sector, can you see a sort of move of HVAC engineers, refrigerant engineers, maybe sort of transition across to this industry, the heat industry, and maybe learning about the wet side and sort of starting to put this equipment in?
If we're rolling out millions, yes, and hopefully that's where we're going to be quite soon. These things, they will break down occasionally. So there will need to be, like your boiler service guy, a refrigeration service guy who can come out and do a compressor change or a transducer swap or a filter, whatever it is on the refrigeration side. That's going to be a useful area to have a good base of service engineers rather than just ripping them out and replacing the whole unit. It's just not economical.
Like they do with boilers.
Maybe, yeah. I don't know much about the boiler industry, but I know there's a great base of boiler service engineers, and I think bringing those over is the natural progression as we see less boilers in the next few years and a lot more of these. I just see this market growing so quickly. You did a podcast recently on district heat. That's going to go big. You've got generation 5 of the district heat networks coming, which is ambient loops, not hot water.
Yeah.
So essentially heat pumps in every single building or every apartment block.
Well, I did a podcast with Kenza because that's the kind of model they use, isn't it, with their shoebox model?
They do, yeah. They got a shoebox. Yeah.
Well, I know the Heat Pump Association were mooting the idea of having a renewables installer qualification. Tail end of last year that I was talking to the chairman of the Heat Pump Association about that, because we do have this issue that we need to install 1 million domestic heat pumps. We don't have the installer base within, if some of them are obviously going to be split type. And we have refrigeration air conditioning installers, a lot of them who don't want to do domestic work. And if you have that gap, who's actually going to install them competently? Because actually the heating sector can't do the refrigerant pipe work part of it legally or competently. And post Grenfell, we're really looking at a situation where competence isn't actually key. It's evidencing your competence is key. That's going to be really critical in building regulations going forward. So you have to have some kind of method of evidencing that competence, and that's why one of the things that's been talked about is a renewables installer training program.
Sounds very promising.
Yeah.
Let's talk about a little bit about diversity, because I am known for sort of talking about diversity in this industry, and obviously you've come into this industry. I mean, how did you get into the industry to start with? I
fell into it, which I think pretty much is the norm for our industry. I crashed out of my A-levels, but I had a national, a flair for maths and science. My mum was an engineer, my dad was an engineer, my granddads were engineers. It's a bit of a family tradition. And a job came up at a local manufacturer of heating and cooling equipment. And I went for an interview and managed to blag it, and it's all gone from there.
And you're still enjoying it, I take it?
Yeah, 20 years now I've been doing this.
And are you quite proactive? I mean, how do we bring more ladies sort of into the industry? I mean, I know when I've taught at colleges, you do get school leavers, female school leavers coming on to the sort of plumbing courses and heating courses. And actually, I've always said to them, you've got quite a good, you can use your sort of gender as a bit of because there are large companies now that will take on females. I mean, in the heating industry, there was a change in the regulations around thermostatic mixers under your basin. So you had to sort of be able to control scalding. Now, obviously, in old people's homes and stuff like that, they didn't really want an old-looking guy like me going in. These old people are infirm in their bed. And I think some companies realised, a trained lady engineer could go in and change that component, and obviously the person in that bed wouldn't get quite scared. And so, because it was tough, I think the opportunity is there to be in the industry, but there is still discrimination, and I've talked about that at some speeches I've done. I mean, have you encountered any discrimination at all?
I mean, there's always going to be issues. I think it goes both ways, and it's more than just being female. There are still, like just generally in life, there are bigots, and you will come across those. And I have seen things, let's say, not always sort of directed at a female, but it could be directed at somebody of ethnicity, whatever. But for us, I work for J&E Hall, and we do try and encourage women to come into apprenticeships, but unfortunately there's not enough females applying to do apprenticeships in refrigeration. And when we look at the figures, I think nationally there's probably about 15% of people that are working in like core STEM subjects are women. In refrigeration, that probably amounts to about 2 or 3%. We're actually way below national average. What I'm trying to do with some of the other female engineers in our industry is to actually raise the profile, to let people know that it's not all oily rags and, you know, dirty hot plant rooms, which we do get stuck in, and then other days you're in a freezer at minus 22. There are days that are not perhaps so fun or glamorous, but there are jobs for everybody. It doesn't, you know, you don't necessarily have to be on the tools. There's the design element of the job. But what I would say is apprenticeships are a really great route in. So definitely, if you've got young people in your family and they're not really sure about what they want to do, perhaps direct them towards apprenticeships, or at least investigating them.
Have you got
Yeah, I'd second that on apprenticeship. That was my route into engineering, was apprenticeship, and it was, I recommend it to everyone, all young people. It's a great way if you want to come out of school, start earning a bit of money, to be honest, and also get experience.
And that's the big win, isn't it? Being paid. I found out when I wanted a car. And
we do have a problem. I mean, I don't know what it's like in the refrigeration industry, but in the plumbing and heating industry, we have a problem because there's not enough employers that want to take apprentices. So we're mainly a self-employed industry, over 80%, and that you'll find most of the apprentices are going to be the sons or daughters of the person, the employer. So we do teach hundreds of thousands of people on construction courses every year at colleges on the diploma courses, who are all doing exactly the same theory and same practical as apprentices, but they're all trying to look for someone to take them on so they can get their full qualification, their MVQ. And we have hundreds of thousands enrolled every year, year in, year out. We just haven't got enough employers to take them on at all. So I didn't know.
Like the current situation isn't helping that either, obviously.
No,
there's a lot of them are struggling with cash flow or just with orders. So the first thing that often goes is actually taking on apprentices, unfortunately.
I think
because they need to try and retain the qualified engineers, don't they? You know.
Yeah, but I think maybe that's the key difference with our industry, is that people that go to college to study refrigeration and building services tend to have a job, an apprenticeship already, whereas the plumbing courses and other trades, you don't need to have that apprenticeship to necessarily go to college.
So that's a very, very good point, actually. So you can't go and do a diploma course for refrigeration. You have to be an apprentice to go and do it.
No, you can do it. It's just very unusual.
Yeah. Right.
Because obviously the plumbing and heating course is very, very popular at colleges. I mean, colleges love popular courses because it's what brings them their revenue. I often wonder, not many people realise how prevalent and big the refrigeration industry is. I don't think they realise all their food is coming on refrigerated kits. It's going into refrigerated storage. It's going into refrigerated lorries. It's even going into these refrigerated little Luton van type things that come and bring it to your doorstep. Refrigeration is everywhere. And I think
it is. Modern life is impossible without refrigeration in some way. And yet, if you ask a school's career counsellor, if they have somebody that's looking to do a trade, they're never going to push them towards refrigeration. They'll push them towards heating and plumbing, electrician, joiner.
I don't think they know about it, Graeme.
No, they don't. We're very much a hidden industry. That's what World Refrigeration Day is all about. We're trying to raise the profile of the industry to the wider sector and let them understand what it is we actually do. I mean, smartphones, forget about it. You can't use a smartphone without refrigeration because you won't have the air-conditioned data centers that are necessary to actually push through that amount of data that's required for smart TVs and smartphones, the internet. None of it's possible without refrigeration in some form.
Yeah, all these server rooms have all got things taking the heat out of them, haven't they?
That's why people like Lisa-Jayne and me are in high demand, you see.
So, I mean, World Refrigeration Day you've talked about, and what other sort of initiatives can we do, maybe?
No, we need to get that awareness raised and a lot more outside of our. I mean, at the moment, World Refrigeration Day, it's only just had its second year, and it was right in the middle of the pandemic, which you're in lockdown still, so we weren't able to actually do a lot of things we all wanted to do this year. But the plan was for this year to get the message out to a much wider sector, out with our own sector, and really shout about who we are as a sector. Hopefully we won't be locked down next June the 26th, and we'll be able to actually get out and make a bit more of it, you know.
Well, maybe we should all sort of have a chat about that. Maybe there's some ideas I can come up with to help with that, because
Great.
like I say, everyone knows a plumber and they know an engineer, an electrician. They all know that when they leave school, and they can go and enrol on them courses at college. I mean, and like I say, hundreds of thousands do. But and I used to teach in a prison as well, and they all know about plumbing and electrical in prison as well. But they don't know about refrigeration engineers. Very few people do, in fact, actually.
Yeah.
But so you work, James. I mean, you've worked on Navy ships, is right? Or you work?
Yeah, I'm currently the company I work for. We've been around like J Hall for a long time. It's 1909. I mean, refrigeration's been around forever, really, in that sense. Started with CO2 and ammonia back there, and that's where we're going now. These are the natural refrigerants we're talking about. We're going back to these. I think we left them because of their flammability, toxicity, pressure. Everything was against them.
Exactly.
The one thing that is now for them is the environment, and we're going to just learn to engineer out, which I think we've really got the ability to do, the risks. And if we can manage the risks and work with them, we can actually have a satisfied environment and solution for ourselves. So I don't see ammonia coming in. CO2, I mean, heat pumps in general, people are, I guess, going to be listening to this wondering, if you're choosing a heat pump, how do you know what refrigerant to choose? And there are simple things that we can talk about that differentiate them. I mean, generally, most of the heat pumps on the market recently were 407C moving to 410A, then R32. And the difference between those is R32 is this new class of, I think it's A2L, isn't it? Right?
Yeah. Yeah.
So it's a mildly flammable.
Lower flammability.
Yeah. So
we're not allowed to say mildly flammable.
Okay. Lower. So in other words, it will burn, but I mean, generally it won't burn in the conditions like below 30 degrees. You won't actually propagate a flame. So they're safe to use, but we still have to refer to them as mildly or low flammability. So that's R32. So R32 is great. It's a very efficient refrigerant, and that was probably the first step into taking the risks of flammability for the gain in performance and GWP. So when you're selecting a heat pump, the two things that you want to look for on a data sheet are the refrigerant, and they won't necessarily tell you the GWP, although it will be written on the unit. And that GWP is the global warming potential of that substance, that refrigerant. The higher it is, the worse it is, simply. So the old refrigerants we were using are up in the 2, 3, 4,000 range, which means for every kilo of refrigerant, it's 2, 3, 4,000 kilos of CO2, essentially equivalent you've put into the atmosphere. But now with these natural refrigerants, we've got that down from those high numbers to almost nothing. It's 2, 3, 4.
Well, propane's 3. I mean,
propane's 3.
600, is it?
Yeah.
What's that?
680, 675, I think it is.
R32, yes. Yeah. So R32 was a big step from, it was around about 2000, wasn't it? The 410.
Yeah.
407. And it does matter. I mean, just last week, we were looking at a job, customer had got a system, not very well maintained. They'd lost 60 kilos of 404A, right? So 60 kilos, you think 60 kilos. But you multiply that for 404A by 4,000, that's 200.
It's a quarter of a million
tons
CO2.
Of CO2. So they've got a plant, it's got 60 kilos. Now 60 kilos is not a huge amount. You think your heat pump will have a couple of kilos in it, potentially. Yeah. An industrial unit's got 60 kilos. You lose that, 250,000 tons of CO2 you've just dumped into the atmosphere. So GWP is a very strong subject now in this industry, not just refrigeration, not just renewables, the whole industry. So GWP, yes, you do want to look for the lower ones, but what you don't want to do is choose a low GWP and then have a worse performing product that uses more energy in its consumption day to day, because GWP only matters if you leak it. Yeah. Now, that's probably at end of life, recycling of the product, or if there's a failure in a component. But assuming that we can calculate the average leak rates and we know the energy consumption of a unit, I think there really needs to be a new measure, and it is in some of the standards.
It's the TEWI, TEWI, total equivalent warming impact.
That's right, and I think that's in 378, isn't it?
They mentioned that, yeah.
Yeah, so that's the total equivalent if based on leak rate, I think, isn't it, Graeme?
Yeah.
And consumption.
Yeah, it builds in about 5% leak rate or something like that. Yeah.
So it's a good measure. So that means you're not going to sacrifice performance wasting electricity to run the product for a low GWP. It just so happens propane, as a good example, because it is the kid on the block now, is a very low GWP of 3, and it's also a better performer. So it really is outstanding as far as a refrigerant is concerned. You've just got this slight problem that it's very volatile. Flammable.
Yeah, that's it. These things are fine as long as they're actually introduced in a controlled way and with safety in mind.
Yeah.
Like we've said earlier, like with the monoblocs, I mean, you're all F-gas engineers. With the monoblocs, you're quite happy that they're safe, and that's because, like you say, that most heat pumps now, I think, are around about R32, but we have got obviously Valent. I think there's a couple abroad that are propane, which is R290. So, and it is apparently a much better refrigerant gas to work with these. I mean, why is that? Just because you guys are more technical than me around it. Why is propane more efficient than, let's say, R32?
Physics. How long have we got?
Yeah, physics. Yeah. So, well, the obvious thing is it's refrigerating capacity. So the amount of fluid you need or substance you need to do the work. As soon as you move to propane, you can just halve the amount of refrigerant you put in the system. So that's a great step, and that's because it's just got this high, if you want to get technical, it's the M4P characteristic, which is how many kilojoules of energy per kilogram per degrees that you put the heat in or out of, and it's very high. Yeah. So you don't have to move a lot of it.
We already reduced that largely by going from R410A to R32. Because R32 is a much more efficient refrigerant. So the actual charge required went down, I think, on average by about 40% on a split system. And then it's halved again by if you can go to R290. So it's all heading in the right direction. But it has to be done in a controlled manner to make sure it's done safely. That's my concern.
Is there one you can foresee that's beyond propane? I know obviously in industrial use they can use CO2, but you wouldn't be able to do that in domestic because of the pressures, would you?
Well,
you can on a monobloc. You can on a monobloc, certainly, because all of the refrigerant is done in a factory environment and it can be made leak tight. Your problem is the power required to run a CO2 system would make it unfeasible when you look at the DSEAR, the total impact, because you're going to be drawing that much more energy to actually run it. So that's why it's not really practical or feasible. But then if you're looking at things like district networks, that's different, because then you're talking about a central plant, and you'd be silly not to look at CO2 in all honesty, because the heat rejection on the discharge side is so huge that you're effectively getting free hot water. So if you're talking about a street of houses, then they could effectively be getting cooling for these last few weeks when you've needed cooling. But the hot water for the houses would be pennies to create.
Yeah, there is a CO2 heat pump. I think Mitsubishi do one for the home, but it really focuses on hot water production. So I'm pretty sure with this, I mean, CO2. So if you're looking at CO2, propane, or the legacy ones that are still in existence. So propane is great all round, it's just the flammability. CO2, extremely high pressures, and it only really favours high delta T's. You're talking 50, 60 degree delta T's.
Great for hotels.
Yeah.
Great for hotels because you've got a high hot water usage.
You want hot water and you want to lower it. You literally are looking at 50, 60 degrees to make it efficient. Doesn't mean it won't work at the 10 or 5, 10, 20 deltas. But your COP then is going to be way down in the 2s, and you're not going to contend with anything that's already on the market. So for CO2, it really is probably going to be teamed up with a large volume of water, well stratified, pulling cold water off the bottom and sticking it in at the top of those big deltas with very high pressure. You're over 100 bar, which is high. You wouldn't want it necessarily in your home. The supermarkets have used it for a long time because they're using it for cooling. So the high pressure, high temperature side is out of the building on the roof or out the back, where all these extreme pressures are. And then for the chilling, you're right back down on the low pressure side. It's not such a risk.
I want to bring in one question, because obviously you guys are all HVAC engineers. Now there's a big question as we move towards these renewables and heat pumps, is why are they so expensive? So as you would all know, in your game, some of this equipment isn't actually that expensive. And we've talked about a split system. You can actually pick up a split system relatively quite cheap, can't you? For the same kilowatt as you would with all these people now buying their heat pumps or monoblocs. Why is this price differentiation existing, do we know?
I think it's the RHI. I mean, a lot of it is if you've got an RHI offering you so many thousands, then that naturally sets the price point for the product. I've had that discussion a lot recently.
Because the products, they're using the same components. They got fans, they got compressors, they got two coils. They're using the same components that are all made, as we know, in a few factories around the world, really, aren't they?
They are. Yes.
So yeah, I mean, it's always. I mean, someone.
There is a VAT implication now that wasn't there before, that came in last October. So whereas basically all heat pumps used to be reduced VAT rate of 5%, split systems that can do cooling as well, the government decided to rule that out. So that did bring in a price differential.
Interesting.
Even though some people actually still market online selling these things saying it's only 5%.
Really?
No, there's actually 20% they should be applying to it. Because the 5% only applies if you're on certain benefits and things like that. There's a calculator on the government website to work out if you're eligible or not.
I think the price though is coming down, and it's got to, because like you're saying, Nathan, the value. I mean, you take a split system and a mono heat pump typically. Why is a heat pump 3, 4, 5, sometimes 10 times the price? The simple answer is it doesn't need to be. I think that they are extremely well margined at this point. And also though, the volume though, you've got to be fair to the manufacturers. The volume is not there like it is with the split systems. They are manufactured outside of Europe, bought in and distributed. Heat pumps, not quite there yet. Obviously, we've got a way to come. But the great news is that all the componentry is shared, typically. Talking like the expensive stuff, like the compressors, filters, all the bits that go into a system, expansion valves, and it doesn't justify the many thousands it costs to go pick up a heat pump, is my personal opinion. So
what about some of the software? Is there software differences? I mean, I'm saying that. I mean, some of these split systems, when they can do all these various things with all their different indoor units, I mean, the software for that is quite complicated and technical, isn't it? I mean, is the software one of the reasons why there's all this price differentiation, do you think?
I don't believe it is. I mean, heat pumps, some of them have got some really good features now, like the APIs, so they can match in with your supplier for your energy. You've got open firms, so they can talk to your thermostats. So there's some really good stuff going into heat pumps. But again, I guess with the volume, there is a little bit of that. You know, they've got those investments to do that software development that is not necessarily on an air conditioning system. Weather compensation.
Whenever I chat to HVAC engineers, I want to ask them what's their favourite brand, but I don't know if I should. Have you got a favourite brand, either of you?
I'm not allowed to say anymore because I work for a trade association.
I mean, obviously, I'm going to name a few for obviously my listeners, because this is all new stuff. So you obviously got Mitsubishi, but there's two Mitsubishis, isn't there? There's Heavy Industry, and there's the other one, and then there's LG, there's Daikin, obviously, Hitachi, Panasonic. I know are getting quite big again.
Valent with their 290. Valent, who's got their new 290 heat pump. Yeah. So
Valent are obviously very, very big in the boiler industry anyway, and obviously you've got boiler manufacturers. I mean, this is another interesting thing, and we'll probably better pick up on this as well, because obviously we've got this thing at the moment where it's quite frustrating for me, because if anyone that knows, listen to me, I'm a solar thermal advocate, and you can use solar thermal in the winter, because I've done it, and I'm not a great engineer, trust me. And we've got this thing about electricity versus hydrogen. So obviously electricity is the heat pumps, and versus hydrogen boilers. So you have got a few boiler manufacturers now sort of, well, I say it's maintaining the narrative. I cannot see our grid ever being able to have hydrogen down. Now, I know they're upgrading the main infrastructure to MDPE, but when you start to get inside people's houses and their internal pipework, as you all know, is we use hydrogen, don't we? It's a tracer gas. We use it to find leaks in pipework. So this idea that we're going to have 26 million homes now having hydrogen actually in their home I think is a massive. I think it's a red herring.
What could go wrong?
But you've got a lot of people, a lot of high up people talking about it, and it really, I don't know, it's really interesting. Are they trying to maintain the narrative so they can actually, if we said that we aren't allowed these gas boilers anymore, the network becomes a defunct industry overnight.
Yeah.
And
I was at a launch of a publication by a select committee in Parliament last year, and that was on the hydrogen networks. The thing is, it's all driven by the environmental demand. So you have, on the one hand, you have the concerns about the environmental impact that we have as a nation, and the desire to stop the burning of fossil fuels, which obviously is hugely important for us to meet our carbon reduction commitment targets. And one of the solutions that was being mooted is hydrogen networks, and that's why this select committee had looked into it, cross-party group of MPs who had commissioned this report, and it was a big launch party at House of Commons I was at last year for this thing, and they're all really excited about this, and I'm standing there thinking, yeah, it's great, I can see why they're doing it, but I really don't think they're thinking about some of the implications, like you say, about you're pumping this hydrogen into people's houses, and it's a very small molecule gas, and it will find this slightest leak.
Yeah.
And it's a very volatile gas as well when it's mixed with air.
We test our internal pipework with methane, with the gas we're actually burning.
Yeah.
So we don't do Sandys tests with, and like you say, you've all got bottles of 5% hydrogen, 95% nitrogen to go out and test for leaks, haven't you? And I think hydrogen's got a place in sort of plant rooms and district heating type scenarios, but absolutely not pumping it to individual boilers. And I think
I think a long-term future, it's not a bad thing to look at, and I think that committee of MPs was right to look into it and bring that report out. I do find it interesting that despite that huge launch they had, and this was back, I don't know, probably last August, September, nothing has really moved on from that. Even politically, it never really moved on from that. And yet we've started talking about things like rolling out the domestic heat pumps. Now, I think that's got a much bigger or easier to gain attraction, possibly, because you don't have the same safety implications, you don't have the same infrastructure demand, because obviously with the hydrogen you've got that whole rollout of the network under the ground through the streets with a huge hydrogen network and all the potential downfalls to that. Whereas with the domestic heat pumps, you have still got infrastructure issues, massive ones, because actually the electric grid isn't big enough to cope with the demand for the 1 million domestic heat pumps a year we're looking to add to the system.
Well, some people would say it is, Graeme. I mean, obviously, as you know, with COP, I mean, obviously people worry if they're going to have I don't know, let's say it's a 9 kilowatt heat pump. You don't actually need 9 kilowatts of electricity coming in. Now,
No.
I've put electric showers into people's homes that they've got 3 en suites. They want 3 electric showers. Right? That's a lot of amps.
Yeah.
I didn't. I made sure the electrician comes and sort of does stuff like that.
The fuse board is like glowing every morning when the showers are on.
I know. I mean, these heat pumps aren't drawing as much as electricity is. Like I say, there's people with 2 electric showers in their homes that they're using at the same time.
Yeah.
That's tremendous. I mean, what's the average now? 9.5 kilowatt electric shower. So that's 19 kilowatts of power direct. Whereas your heat pump with a COP of 3, it's not drawing to put out.
Yeah, but if the problem is that if you have a street with 100 houses on it and they all put in domestic heat pumps and they're all drawing that kilowatt or 3 kilowatts, whatever, of power consumption, that's an extra 3 kilowatts that the grid hasn't been designed for, because the national grid already say that the grid that is out there is already at capacity. That's the trouble, particularly with some of the inner cities.
I think we've got to look at the grid, because with not just heat pumps, electric cars. So I've got an electric car, and I plug that thing in, and it's 7 kilowatts straight away. Now my heat pump, for comparison, is more like 1.5. So that's not the problem. I think you're talking other areas of the grid in general needs to be assessed. I mean, they're offering, in my example, I had a 60 amp supply. They offered me 100 amp free of charge, but we're all going that way.
Yeah.
So in general, it's going electrified. What I don't like about hydrogen is the round trip efficiencies. We're talking heat pumps here, 3, 4, 100% efficient. The round trip for hydrogen, if you start with electricity, is much less than 1. It's obviously less than 1. It's really low. So is it the best use of, if you're going to use electricity to produce hydrogen? Certainly not, but that's part of the argument, I believe, is to use renewable electricity when it's abundant.
Yeah.
But how about if we just made our grid or our homes a little bit more intelligent and use the grid to offload that abundant electron as opposed to a hydrogen molecule, and stick it in the car, run the heat pump, do your hot water at 2 o'clock in the morning, which is what my system does. And there's great tariffs around now that pay you to use electricity. I think that's been discussed. So it's going in the right direction. I think hydrogen's got a longer road than what we currently have, which is existing technology. We've got the grid. We haven't got a hydrogen grid at all, but we have got an electric grid ready to go. If you just put smart heat pumps in and suitable systems that didn't, and that's, let's be honest, heat pumps are not a fast-acting, fast response heating system anyway. So where we come in from home, flick on the gas boiler, and in half an hour everything's nice and warm, that's not going to happen anyway. And people have got to get used to that sort of mindset. The better off, and that's really not let the people manage that, but let the systems, the infrastructure, intelligently manage that through software. So these heat pumps, if they're all linked on a network, they talk to each other. There's a ton of spare electricity tonight. Let's just run everyone that's happy or has got the capacity to absorb it in their car, in their home, in their hot water tank. I think it's really exciting time for electrification in general. And we see it with hydrogen cars. It's the same argument. They've been struggling because they don't have the infrastructure to refuel. You know, I know someone in LA, he's got a hydrogen car, but he has to sometimes wait for the pump to be ready, or if the pump's broken down. And the pump, let's talk about that. The hydrogen, he's putting it in, I think it's 400 bar. So, you know, we're worried about CO2 heat pumps and stuff, but you've got other problems around. It's engineering. That's what we do, right? That's why we love this. Let's just solve a few problems. But with hydrogen, I'm not yet convinced. I'm always open-minded about these technologies.
It's an interesting, like I say, I think hydrogen definitely has a place somewhere, and maybe even new builds in the future, but definitely not going in. I mean, I worked as an apprentice on one of the biggest building sites in the country, I think, in Norfolk. It's 5,000 homes, and I did a lot of that gas carcassing. There's no way I'd want that hydrogen running through that carcass. It's going to leak. You know, it's a very, very small molecule. It might be okay for plant rooms. It might be okay for new builds maybe, but once again, new builds should really be having solar thermal and heat pumps as far as I'm concerned. It's I don't know what's going on with our new build at the moment. It's diabolical, if you ask me. Well, it's been really interesting chatting to you people. I think we're going to have you three back again because you're my sort of F-gas people, I suppose. So we'll definitely be doing some more podcasts around it, because I think people are starting to sort of realise heat pumps use a refrigerant, and it's a very sort of important topic in its own right, isn't it? And I think it's sometimes not talked about enough. So I'd like to thank Lisa, James and Graeme. Thank you for coming along today and giving up your time. And Graeme, you're probably going to go off and play a bit of, I've noticed your guitar in the background.
Yeah, unfortunately, I've got a shed load of emails I need to go and deal with.
You're not going to entertain us with Comfortably Numb then or something?
Not right now, no.
Thank you ever so much, and hope to see you all again. Thank you.
Thank you.
Thanks.
Cheers. Bye.
Bye.